All right, welcome everyone. Thank you so much for joining today. Today we're going to be talking about innovative design applications utilizing advanced fire-rated glazing technology. We've got the team from Safety First here today. Michelle Murray is going to be giving our CEU presentation, and we've also got Armani and Jennifer on today to help out with answering questions. My name is Bo. I'm here with Acelab. We're helping out with hosting today's event. My colleague Helen is going to give a quick little introduction about Acelab, show you guys how to find the safety team on Acelab. So if you have follow-up questions, that's a great place to go, explore more about their products and get in touch with their team directly. A few housekeeping items from me. We did ask for AIA numbers upon registration. I will also send over a form in the chat momentarily in case you're worried you didn't include your AIA number. You can submit it there as well as request a certificate through that form. Other than that, just want to encourage folks to please submit questions to the Q&A throughout today's presentation. We'll have some time to go over those towards the end of the presentation. And other than that, I think we're all set. So Helen, feel free to take it away for a quick little intro, and then we'll get started with today's CEU course.
Awesome. Thank you so much, Bo. Hey, everyone. Nice to be here with y'all on a Friday. I'm going to go ahead and share my screen. I'm Helen. As Bo mentioned, I'm the Director of Architect Experience here. My job is to make sure all of you architects are having a great experience on the platform. And I have my MArch as well. So today I'm going to quickly show y'all a couple things you can do in Acelab, and then I will show you how to get in touch with the folks at Safety. So here we are on the home screen. I'm going to jump into my workspace here. You can see I have a lot of conversations going. But I'm gonna jump into projects. I want to show y'all an example of how you can use Acelab. So you can search for things, you can create conversations with the folks at Safety and other manufacturers as well. But another cool thing you can do is you can really build out some projects as well and save all the products that you want to be using for that project in that folder, and then collaborate with your team on it. In honor of Earth Day earlier this week, I'm just going to jump into sustainable alternatives here, show y'all what this can look like. So here you can have just, kind of a running list of your different maybe cladding types or coatings that might be a little bit more sustainable than other options, decking and pavers that might be, meet the declare criteria, etc. So this is just one application of how this can look for you. So again, this is an example of how you could build out a sustainable library, invite everyone from your firm into it, so everyone has easy access to, kind of search and understand a little bit more about some of these potential alternatives that you could use. All right, if you come to a lot of these webinars, you've probably seen me before, and what you'll see after this webinar is that you'll complete your poll and you're going to note the information you might be requesting from Safety First. And what you're going to see then is that either myself or my colleague Evelyn will be creating a conversation for you. So if y'all want to respond there, we encourage you to do that. Have a great conversation, let us know the project type, the location, things of that nature, so that the literature, whatever you're requesting, can be tailored for you. So you can always respond to that conversation from your email now, but you can also jump back in here and you can see those conversations and respond there as well. So really encourage y'all to use this as a great way to communicate with the folks at Safety First. One other note too, if you're in a project and you have a conversation, your whole project team can also see that. Last but not least, let's talk about how to get in touch with these folks. So you go up to the top bar here, make sure you select brands, and then you can just start typing in the brand name, whether you're looking for Safety First or other folks. And here you're going to be able to contact them by selecting this button. And then further on down, you can see all of their products. And then you can, again, save these into your various projects if you're interested in them or want a little bit more information and create some comparisons. I do trainings about how to set up and organize all this for your firm based of your firm's needs. And I'd love to chat with y'all. So I will pass it back. Thank you so much for letting me come and chat with you.
Awesome. Thanks so much, Helen. I'm going to launch a quick poll if anybody's interested in hearing a little bit more about using Acelab and connecting with Helen to learn how you can use our platform for your projects. Feel free to say yes to a demo on this poll, and we will reach out to schedule a quick time. All right. Without further ado, Michelle, whenever you're ready, I'd love to hand it over to you to get started with today's CEU presentation.
Great, thank you. Thank you for having us. Just do a quick introduction. My name is Michelle Murray, and I am the architectural sales rep for Safety First. And we are going to give an AIA presentation today on innovative design using fire-rated glazing technology. And I'm not sure how much everybody knows, so this does a little bit of a deep dive into just understanding the products. For some housekeeping. And the learning objectives today, we're going to look at the history of fire rated. So understanding kind of where fire rated started and where it is today. I always say to people I present to that the second objective really is really what you want to take away from the presentation. And that's understanding the difference between fire protective and fire resistive glazing and how the IBC distinguishes between these two. We'll look at how the architectural community, i.e. everybody out there, wants bigger glass, better clarity. And then lastly, looking at the importance of multifunctional. So not just having a fire rated glazing, but having fire rated with maybe a ballistic or forced entry or hurricane. So first, let's look at the history of fire rated glass. On the left, you'll see the old solution, which truly was no vision whatsoever. You had no views. It was opaque. It was typically brick, concrete, some sort of material that you could not see through. A technology came along that people thought would work was wired glass or ceramics used in door lights. Even now, we consider that a little bit of older technology because they did have limitations. When you use wire glass or ceramics in a door or a side light where people could bump into it and break it, there is a safety issue. So the federal government decided, well, we need to make some standards for this to make sure that people aren't injured when they are having this type of glazing in areas that could be impacted. So for any opening less than 1,296 square inches, it needs to meet the impact of basically 150 foot-pounds or a small child running into it. So that glazing needs to withstand breakage if it's less than 1,296 square inches. If it's more than 1,296 square inches, now you have to be able to take the impact of 400 foot-pounds or basically an adult running into it without breakage. The evolution has continued. On the left, you'll see the clear specialty fire protective, and that's just showing the clarity now that you can get in these fire protective glazing options. On the right of that apple, you'll see kind of the older technology. Again, a little bit of amber tint to it. When I started back in 06, 07, it even had like a funhouse mirror effect, you know, where you stand in front of a mirror at the fair and your head's big, but your body's small. So the clarity has really come a long way. And then on the right, you'll see a new technology also for larger, clear, transparent, fire resistive. And we're going to get into that in just a moment. So the evolution of fire-rated glazing also includes being able to have multifunctional. So whether you have a 60-minute application, you can also add ballistic or blast, or if it's exterior, you need to add some thermal value. So you'd put a UV on it. There's acoustic and artistic, and we're going to take a look at that stuff later on. But these are just some of the options that are now available with fire-rated glazing. So where can it be found? You've probably seen it mostly in fire doors or fire openings, maybe borrowed lights, probably in doors going into a corridor, classrooms, you'll see it a lot. But there's also fire resistive barriers, meaning that's a wall assembly, and you'll see full walls to even floors now, where you have load-bearing floors that are a 1 or 2 hour fire separation. So what is the difference between fire protective and fire resistive? Well, there's a couple of different things you should understand. The glazing falls into two categories, fire protective or fire resistive. Now, fire protective would be considered an opening like a window or a door, and a fire resistive would be something considered a wall assembly. And they are both tested to contain flame and smoke. So whether it's a door or a side light or a wall. But when you become a wall, a fire resistive assembly, now you need to compartmentalize that flame and smoke, but you also need to block the radiant heat. And that's the key difference. Typically, you're going to see fire protective openings being at 45 minutes or less. So you're going to meet NFPA 257 and 252. When you get over 45 minutes, you are now considered a wall assembly. And you basically think of it as a transparent wall. So if you had a rated gyps board of 1 hour, or any fire resistive glazing that meets the ASTM E119 is also considered a wall assembly. So that really is the key difference, is having that radiant heat blocking ability. So how do we test fiberglass? So what determines the amount of time is how long it's tested for at X amount of temperature. So it can range anywhere from 20 minutes up to 3 hours. So after you've heated up this piece of glass for 90 minutes or so, what's the best thing to do is to put a hose stream to it. So after a glass is heated up for a duration, water is delivered via hose stream. And this isn't for a thermal shock testing. This is about a structural test. And with ASTM E119 and UL 263, no glass can come out of that opening. So basically you heat your glass up and then it's not meant to necessarily mimic a fire hose, but it cannot have any glazing loss. NFPA 257 allows for 30% of that separation. The hose stream test really is only used now in the US and Canada. In the US, anything at 45 minutes and above needs to meet hose stream. Most jurisdictions will give you the okay to do a 20-minute without the hose stream. So we talk about radiant heat, but what is it? So radiant heat are these invisible magnetic waves that travel through the air, and they're pretty much unimpinged. They're not stopped by anything until they hit something, and then they are stopped. Well, if what gets in their path happens to be combustible, wood, paper, over time, that material can combust. So we're going to look at a radiant heat comparative test. Now, I don't want this to look like we're showing you failure. This is not to show failure of glass products. This is just to show you that these are fire protective, meaning they contain the smoke and flame, but they do not block the radiant heat. So this is not a failure of the test. This is just showing the limitations of the fire protective product. So just to review, a fire resistive glazing is basically defined as meeting the fire endurance test, which we saw, the radiant heat test, and a hose stream test, which we saw. So if you meet those 3 criteria at 60 minutes and above, you will be a fire resistive glazing and you meet the wall standard, which is ASTM E119. So what do these products look like? So these are a couple of examples of fire resistive glazing products currently on the market. On the left, you have two pieces of clear tempered glazing with an intumescent inner layer. That would be the fire retardant in that space. You also have a multi-laminate where you have layers of annealed glass. And again, you'll have an intumescent layer in between, which would be your fire barrier. So how does it work? So in a testing, the glass is exposed to fire. One side of it is exposed to fire. By design, that light of glass will break, activating that intumescent inner layer. The fire retardant absorbs the moisture and basically becomes like a char, like an ashy char. That is how it remains to be able to block the radiant heat. The glass temperature remains low and the radiant heat is blocked. If you do have a fire resistive opening, a wall assembly, you need to have a framing that also meets the criteria of blocking that radiant heat, keeping that unexposed side below 250 degrees. Looking at learning objective number 3, we're going to look at bigger glass sizes, a lot of low iron for optical clarity, and then thermal performance for exterior use. Glass sizes have really come a long way from, 2x2 pieces of fire rated glazing now up to 10,000 square inches for 2 hours, doors up to 10 feet. We have a couple of case studies. This is a warehouse on 520 West 20th Street. And basically this is a repurposing of a historic manufactured building into a mixed commercial space in Chelsea. The 3-story glass and steel addition was added on to an existing 4-story brick warehouse. So it was really important for the architects to maintain clear views to the landmarks around the area, including the Empire State Building. And unfortunately, with New York being so compact and condensed, lot lines, proximity to lot lines mandated a 2-hour rating, 2-hour fire resistive rating on one side. So each of these panels is 11 by 5 feet, which was unheard of at the time when this was installed. It's the largest individual lights for fire resistive glazing in the US. And low iron was also used for better clarity. This is the Starbucks Reserve Roastery. This used to be a crate and barrel on Chicago's Magnificent Mile. And inside, it features some design elements such as a 4-story mural by a Chicago artist. And to allow that mural to be visible to visitors, they had to open up the staircase, and it's a 2-hour fire resistive assembly. This is a butt jointed application. Each panel is over 10 feet high. Again, low iron was incorporated to give better clarity. The doors are 10 feet with no transom, and because they are 90 minutes, they are using a fire resistive 90-minute glazing to allow for no breakage in that, no mullions in that. This also encourages visitors to utilize each of the areas by stair instead of by elevator. Okay, looking at optical clarity, this is the Harvard Business School, Klarman Hall. So at Harvard, they are all about the fundraising. So this is a state-of-the-art 1,000-seat auditorium and gathering space. This 2-hour glass wall separates the lobby from the auditorium. providing a visual connection between them. They do a lot of fundraising in this lobby area. Since it's a 2-hour glass wall, it also serves as the entrance. Those doors are 8 feet, I think it is, custom hardware. It's low iron, so it's a 90% visible light transmission. 2.5-inch profile for the framing to give it a slim profile. Also in those doors, they had concealed vertical rods incorporated into them. This is the University of Wisconsin School of Business Learning Commons. Typically you see stairwells that are dark, tucked away in a building. This staircase is reimagined. It is centrally located, and they thought it would be a great idea to make it transparent and ideal for everyday use. This has a clear butt joint, and it's a 1-hour opening. 9-foot, 60-minute temperature rise doors were used. And again, allowing the glazing to be greater than 100 square inches in the door. They used a fire resistive glazing material. This is Waste Management Headquarters. This is a 2-hour stairwell. It's kind of a focal point between 2 floors. These are 9-foot by 8-foot panels, again with a butt joint, and they use an ultra low iron for maximum clarity. Some unique applications. This is actually one of my favorite projects to talk about. This is the Porsche Design Tower in Sunny Isle, Florida. And this features 3 fully automated car elevators. So basically taking residents from the first level up to their units. The shafts are required to meet fire requirements. So these are all 2-hour rated. There is no parking on site on this building, and 60 stories. Basically, they park their car next to their condominium. Once they're up at their condominium, they also have that fire wall barrier that meets ASTM E119. So again, it's a 2-hour rated elevator enclosure that takes residents up to their units. Thermal performance is very important for exterior units, so it's important to incorporate a high performance low E. This project is the Aspen Art Museum. It's designed by Shiguri Ban. So it's a woven wooden screen enclosure that encloses the curtain wall. Sections of this curtain wall also enclose an elevator, which they wanted to leave glass. So this had to meet the 2-hour fire resistive wall criteria. So they were able to put in fire rated glazing with a high performance low E. It needed to perform in this extreme climate because it is in Aspen. Thermal analysis was done to ensure that it was insulated, and then also to make sure that it performed as well as the non-fire rated units. Dynamic curtain wall testing was done, thermal cycling and condensation evaluation were also performed. This is the Cortland. This is in New York City, and we do see a lot of property line projects in New York. And what stands out about this one is it was a renovation, and during the bidding phase, it came to our attention that the installation would need to be done from the interior. And so it was a little bit of a game changer, but it was able to be performed, installed from the interior. So it now is another option of installing for facades. So a lot of times you're going to be on that property line requirements, but you want to have it in there without sacrificing any of your design. This is one Sullivan Place. The cantilevered section there is basically protecting air rights for the building next to it if they were to build up. Next, we're going to look at the demand for multifunctional, again, talking about fire-rated products that also incorporate some other type of specialty glazing, whether it's exterior, ballistic, forced entry. The first case we're going to look at is the VA Orlando Medical Center in Florida. This project is a 2-hour fire-resistive, hurricane-rated curtain wall system. So it's tested to TAS 201, large and small missile standards, TAS 202 for uniform structural load standards, and then TAS 203 for uniform cyclic pressure standards. It did incorporate a high-performance, energy-efficient glazing that also matched the rest of the non-rated areas. This project was shipped as a factory glazed modular system for easier installation. This is an Army hospital on the West Coast. It was classified as a critical facility, so it had additional requirements for blast hazard mitigation and for some anti-terrorism standards. Sections of the curtain wall had to meet a 2-hour fire resistive rating. It does have a staircase beyond it. And the design called for fire and blast rated curtain wall that spanned 45 feet and canted out a few degrees. So you can see that on the left that it's canted a bit. That glazing also matches the rest of the exterior non-rated glazing. Getting a little more tricky with fire, ballistic, and forced entry rated. This is the Plaquemines Detention Center, Plaquemines Parish Detention Center in Louisiana. This was damaged by Hurricane Katrina, and funds were available through FEMA to rebuild a facility. The new design called for wire-free 45-minute rated. It needed to be UL ballistic level 3, and then grade 2 that met ASTM F1915 for their control room. So the new design specified glazing common areas to give supervisors line of sight while still providing secure separation, physical containment, and protection. Fire-rated floors is a somewhat new category. This is a 2-hour fire resistive glass floor with decorative glazing. This is here in San Francisco. The fire resistive glass floor enables natural light to reach the subway space below. It's a modular top-loaded design for easy installation. So this is a USA-made fire-rated glass floor, and it met the Buy American requirement for the project. The floor isn't just on the outside. There are elements of it on the inside. The elevator enclosures are all rated. This is the 21C Museum Hotel, another example of a fire resistive floor. It's 1 hour rated, has a non-slip, and it's tempered laminated. The design featured a glass floor on the second level that would act as a light well. This is the largest tested and listed individual glass pane for a fully supported and butt glazed 1 hour fire resistive floor. So that concludes the CE portion of the presentation. We can take questions at this time. First, we're going to show you a video of our company. This is Safety First, privately held company. Our manufacturing in Merced is 4 separate facilities for glass frames, doors, and we also manufacture aluminum ladders. We are completely vertically integrated. What that means is that we're not reliant upon outside manufacturers to make sure that our lead times are not only competitive, but they're met. I don't know if my video stopped.
Right. Saw a comment from someone that they aren't hearing audio, but I think this video doesn't have audio. So,
Right, this one doesn't have audio, sorry.
all right. Well, if you'd like, we can get started with some of the
Yeah,
questions while this plays in the background.
sure.
And I also just want to mention to folks, if you have a question that you'd like to ask out loud, feel free to raise your hand. I'll keep my eye on that. We can unmute you. You don't have to turn your video on, so it's not super scary. But if you have a longer winded question or, something specific you want to ask out loud, feel free to raise your hand. Um, all right, let's start off here with what is the thickness of glass assembly in 90-minute and 2-hour rated in the interior glass system that you showed?
So 90-minute is going to be an inch and a half interior, but the thing with 90-minute glass, we don't really see 90-minute walls, so you're going to see that in a door most of the time. 2-hour is 1 3/4. So a 2-hour wall interior would be 1 3/4 inch glass.
Cool. All right. And then what type of sealant is used between glass panels in butt glass rated system?
So you can use a standard silicone as long as that joint remains less than 1/2 inch. For that butt joint, it needs to be less than 1/2 inch, and then you can just use a standard silicone. If you go over that, which most people don't, you would just need to use a fire rated product.
All right. In the San Francisco Metro station, how is colored glass design incorporated into the glass sandwich?
So on that project, I didn't work on it, but that project, from what I understand, so we build a fire rated glass floor, and then we would take the art glass, which would be laminated, and then build basically an IGU out of it into the fire rated unit. So the whole unit is one IGU. It is multiple layers of glazing, but is all encapsulated into one insulating glass unit.
Awesome. All right. Do you have any UL assembly numbers that we can reference or send after the
Yes, we have, we do have UL assembly numbers, and each product has their own. So I don't know what those numbers are. We can send you the reports for everything. All of our products are listed with Intertech. So all the glass, the frames, the glass and frames as a system, the floor, the doors, they all have Intertech listings. For the UL, we just need to know what product they're looking at, and we can send them the appropriate UL number.
Awesome. All right. Looks like that might be the last of our questions, but
Okay.
let's hang on for another minute or so. If anybody
Yeah,
has a question, feel free to send it in now. We also will have a quick survey that'll come up after you leave today's webinar. So if any other questions come up, you can feel free to leave it on the survey there. I did drop a bunch of links into the chat. So before you head out today, grab some of those links. One of them is to get to safety's page on Acelab. That's another great place to go. If you've got any questions after today's event, you can get in touch with their team directly through that link just by clicking that contact button. All right, let's see.
Do you want me to stop sharing at this point, or should I leave it up?
You can leave it up for now.
Okay.
Yeah, give folks a minute to grab some of that info.
Of course.
All right, cool. Let's see. Do one more call for questions. But if not, we can let everyone head out a little bit early today on this Friday.
Yes.
Yeah, I know. Everybody gets back a few minutes of their day, which is nice. But first, just want to thank everyone in the audience today for joining. We really appreciate you coming out on a Friday. I know that, Fridays these days can feel tough to concentrate as our weather's getting a little warmer. So really appreciate everybody who was able to join us today. And thank you so much, Michelle, for a great presentation, and everyone on the team for joining us today.
Yeah, thank you for your time, everybody. Really appreciate it. And I hope everybody has a great weekend.
All right, I hope so as well. Real quick before we jump off, I just saw a question regarding AIA numbers and continuing education credits. So David, we did ask for AIA numbers upon sign up. Those credits will be reported directly to the AIA. If you are worried you did not submit it there, I did drop a link in the chat to a form. I'll type it as an answer to your question now too, so that you can grab that. But yeah, anybody who needs that AIA number form, grab that from the chat now. Please try to get that in, like, honestly, after we end this webinar, that would be great. Just do it as soon as possible. Before the end of the day would be perfect. That way we can make sure we've got your information. All right, cool. Other than that, I'm just seeing some thank yous in the Q&A. So thank you, everybody, so much.
Thank you. Appreciate the time.
Have a great weekend.
All right.
All right, bye.
Bye-bye.